So now we'll discuss what happens when we consider contact forces as the action reaction pairs. So to consider this, we have only A, but of course we also need B for this. Now, when A is placed on B, when the 5 kilogram block rests on top of the 25 kilogram block, what we see is the 5 kilogram block pushes down on the 25 kilogram block. So it pushes down like this. So we can say that due to this push, the action can be A pushing down on the block B. Okay. Now, very similarly, what happens is the block B, it also pushes back A, or in other words, 25 kilogram block pushes the 5 kilogram block as well. So A is pushing B, B pushes back. Now, this pushing back can now be considered as the reaction, right? So A will have a reaction on block from block B. So A will have a reaction from block B. Now, if we were to consider this, block A experiences both action and reaction. Action pushing down on B, and reaction will be block B pushing up A. Okay, so action and reaction. So action is normal reaction on A due to B. Sorry. And reaction is normal reaction on B due to A. And this direction is really important. Why? One is downward and the other is upward. Also, both of them are acting on two different bodies. Okay. Now, as I said, the magnitude would be the same, but they will have the opposite directions and they act on different bodies, A and B. Now, again, why is this important? Because this matches with every keyword present in the Newton's third law. Action reaction equal opposite acting on two different bodies cannot cancel. Why can't they cancel? Because they act on two different bodies. Okay. Now, this is about contact force. So we did only A, gravity, and contact force. Now, there's something in addition that I want you to know, which is about the free body diagrams of the system of masses. Okay. Now, how do we look at this? To draw the free body diagram of A alone, we'll first have to consider all the forces that are acting only on A, and then body diagram of B, and also free body diagram of the flow. Okay, so I'll do A and B, and you'll have to do flow on your own. And please get back to me on that. Okay, so free body diagram of A. While considering A alone, let's draw all the forces that act on A. Which all are they? There are two forces. One, weight acting downwards, and normal reaction on A due to B acting upwards. So this is weight acting downwards, and then we have the normal reaction from B acting upwards. Okay, so you got two forces for free body diagram of A. Now coming to free body diagram of B. So we isolate the body, we consider only the forces acting on B, which of course would be how many? Two or three? Exactly three. Why? One would be the due to gravitation, exactly weight of the body pulled downwards, force on B due to earth. Second would be the contact force. Wait, yeah. Second would be the contact force that is acting on B due to the contact with A. So force on B from A. Third would be the contact force or the normal reaction on the body B due to flow. So you got three forces here: gravity from A and from flow. Okay. Now, this itself can be of two cases. One, when the body is at rest. Two, when the body is in motion. What do I mean? What I'm trying to say is when this system is at rest, these forces balance each other, which means the upward force will be balanced by the downward force. And therefore, force acting upwards, which is normal reaction on B due to flow, would be equal to forces acting downwards, sum of forces acting downwards, force on B due to A plus force on B due to E. Okay. Now, this is the condition when we say B is at rest. But what about B is in motion? Exactly like the one we have in this given problem. So when B is in motion, what we see is sum of all the forces in the y direction, in this case, will be equal to mass into acceleration along that in the y direction. Now, how do we find sigma Fy? Along the direction of motion. So since the body is moving along the direction of motion along negative y-axis, all forces along this would be considered as positive, and all which are moving against would be considered as negative. So since these two arrowheads are along the direction of motion here, these would be considered as positive. And since the arrow is against the direction of motion, this normal reaction would be considered as negative. And therefore, you have two positive and one negative equal to mass of block P into acceleration of V along the negative y direction. Okay. So, yes, so this is what I wanted to share with you regarding free body diagram and the contact forces. So, we have gone to my best detailing of the NCRT, the problem that was given to us. Okay.